Hello, this is the recitation for homework 1. Homework 1 focuses on the average power computation. I just finished grading your homework and I found some students still have problems doing the average power computation. Let's take a look at question 3. Question 3, the voltage is given, that is 10 times sine 2 pi t, and there are two questions. Given, the first one is given IT equals 5 times sine 2 pi t, and the second question is that IT equals 3 times sine 4 pi t, and ask you to calculate the average power. For the first question, we can use the definition of average power, that is Vt times It, and do the integration, take the average. So the answer should be, that is T1 Vt equals 10 times sine 2 pi t, It equals 5 times sine 2 pi t. So here we got 50 sine squared 2 pi t dt. And the sine squared equals half 1 minus cosine 4 pi t. So we can simplify this equation to 25 minus 25 cosine 4 pi t dt. There is no need to calculate this integration. This is because the average value of sine or cosine function equals 0, because for sine function, the average value equals 0. The same for cosine function. So there is no need to calculate the second term. So the answer is 25 watts. This is use the definition of average power for the calculation. There's a simple way to calculate, because we know that the frequency of the voltage and the frequency of the current, they are the same. So we can use this equation, that is P equals V RMS value times IRMS value times cosine alpha minus beta. Alpha and beta are the angle of the voltage and current. Here, in this question, alpha and beta both equal to 0. And we can use the RMS value, that is 10 over square root of 2 times 5 over the square root of 2. So that is 25 watts. That's the solution for the first question, when I equals 5 times sine 2 pi t. For the second question, the IT equals 3 times sine 4 pi t. Many students didn't get the correct answer, because many students use this equation to calculate. Many students got 15 watts, but this is not the correct answer. This is because the frequency of the voltage and current are not the same. So we cannot use this equation. We need to use the definition of the average power to solve solve the scenario when the frequency of the current and the voltage are not the same. So we need to use this equation. 10 sine 2 pi t times 3 times sine 4 pi t. So we get 30 times sine 4 pi t times sine 2 pi t dt. This equation can be simplified. So there are two terms in this integration. The first term is cosine 6 pi t. The second term is cosine 2 pi t. We know the average value for the cosine function equals 0. So the answer should be 0. That's the answer when it equals 3 times sine 4 pi t. Question 4 is similar to question 3. The voltage is given and there are two currents. For the first question, it equals 5 times sine 2 pi times 60 t. So we use this equation, use the voltage times the current. Because this is a sine function, so the average value equals 0. For the second question, it equals 2 plus 5 sine 2 pi 60 t. So we have the voltage times the current. There are two terms by simplifying this equation. The first term is 24 and the second term is 60 times this sine term. This sine term, we know the average value in one period for sine function equals 0. So the answer should be 24 for this question. In question 5, there is a current source, inductor, resistor, and a DC power supply in the circuit. And the current is given, the inductance is given, resistance is given, and the voltage of the DC power supply is given. And it asks you to determine the average power of each element. For the inductor, it's obvious that the average power of the inductor in steady state for a period equals 0. So PL equals 0. For the resistor, we use the RMS value squared times the resistance. So we can obtain the average power on resistor is 68 volts. For the DC power supply, we use the same method in question 4. That is, we do the integration, and there is a DC component and there is a sine component. The average value of the sine component equals 0. So the answer equals 20 volts.